ROS2 communicates through a middleware called Data Distribution Service, unlike ROS1, which uses Transmission Control Protocol ROS or TCP-ROS. This communication happens between what is called nodes. Each node can send and receive information to other nodes through topics, services, actions, or parameters. Nodes are usually contained in executables like C++, Java, or Python programs, and an executable program can have more than a node. Let's do some demonstration. Fire up a terminal, otherwise known as a bash shell, by pressing Ctrl-Alt-T on your keyboard. ROS is installed in an environment or workspace, and you have to source that workspace every time you open a terminal or bash shell to access the features in ROS. You can either source the ROS workspace permanently or do it every time you open a bash shell. We have both ROS1 and ROS2 on our computer, and we'll prefer sourcing our ROS2 workspace when we launch a bash shell. To source your ROS2 workspace, simply type source, followed by the ROS installation path, and then a bash file called setup.bash. Now we can access ROS features and commands. Nodes are controlled by executable files, which usually reside in packages. Basically, to run a node, you type ROS2, run, the name of the package where the node is, and finally the executable file. We're going to run a node called TotalSim. To run TotalSim, type ROS2, run, TotalSim, and the executable, which is TotalSim node. TotalSim is a 2D simulator that comes by default if you do the ROS desktop installation. It comes with packages that help to test ROS programs and give you an idea of what you can do with a real robot or robot simulation. ROS comes with a bunch of tools to help introspect on ROS programs. We're going to use some of the non-GUI tools to understand the TotalSim we're running. To list all the nodes our ROS program is currently running, we simply type ROS2, node, and list. From the terminal, we can observe that the only node we are running at the moment is called TotalSim. Now let's set our turtle in motion. To move the turtle around, we will run another node under the TotalSim package. Remember to source the ROS workspace before running the node. Type ROS2, run, TotalSim, and the new node executable name called TotalTeleopKey. While active under the new bash shell, where you run the TotalTeleopKey node, use the arrow keys on your keyboard to move the turtle around. Here's a quick explanation. As you move the turtle around with the arrow keys, the TotalTeleopKey node publishes velocity command messages to a topic called Turtle1CMDevel. The TotalSim node then subscribes to this Turtle1CMDevel topic and uses the message contained in it to move the turtle. Before moving to another command option under the ROS node, let's check the list of nodes we have running again. We can now see a new node running alongside the TotalSim node. Still on the non-GUI introspection, certain information about nodes can be obtained. We're going to check the information about the TotalSim node. To introspect the TotalSim node, simply type ROS2, node, info, and the name of the node we want to check. From the information displayed, we can see the TotalSim node uses several communication interfaces such as topics, services, and action. Try using the info option to examine the TotalTeleopKey node and check the communication interface it uses. So, you've learned what a node is, their means of communication, how to run them using the Turtle Simulator package as an example, and how to introspect nodes with a list and info command. In the next lesson, we'll discuss another concept in ROS called topics.